I'm Anthony Watts, Senior Fellow for Environment and Climate from the Heartland Institute, and I'll be hosting Climate Change Roundtable today. Our regular host, Andy Singer, is out with the C19 Scourge, and so I'm running the show today. And with us today, we have our usual regulars, Linnea and Sterling, who will be talking about, well, climate tipping points. One of the topics that we've had in the media this past week has just been all over the place. It's just been an absolute, it's been like a party for the media with all of these things. And they're just talking about doom in the future. And not like this hasn't been heard before. Climate tipping points is something that the media just grabs onto and will not let go of. So we're going to be talking about that today. First, I'd like to talk to Sterling and see how you're doing today. What's news with you?
Well, it's a beautiful day here in sunny Texas. I expect to use my pool for the last time this summer. It's getting cool at night, and so even though I lived in Ohio and swam in colder weather, it's getting a little cool. My wife won't be joining me. When you get into it, Anthony, I want to point out, you talk about doom and gloom all the time, but tipping points are a very particular kind of doom and gloom. It's not that we sort of gradually hit bad things over time. It's that we drop off a cliff. It's like suddenly we hit a point. Everyone's seen those those rocking birds that tip back and forth into water.
And the dunking bird.
The dunking birds. And
right.
Everyone's seen those. That's what a tipping point is. It's like, oops, boom, it's all over. And that's just, there's no evidence whatsoever for that.
Yeah. Linnea, how are you today? And what's news with you?
Well, I'm hoping that if we are at the tipping points, then maybe finally we can work on mitigation instead of prevention in terms of the climate catastrophe that's looming. Do you think there's any chance, Anthony, that we'll be able to convince them that since it's already too late anyway, that they may as well just stop with the alarmism?
I've never been able to convince any climate alarmist of anything. I mean, it's just amazing how one-mindedly stubborn they are. I mean, for example, when I show them pictures of these corrupted weather stations, the ones that are in the middle of a parking lot with an automobile radiator next to it, they go, well, that doesn't matter. Yeah, we can filter that out. Statistics, then they're like, they just want to deny the fact that the climate measurement system isn't perfect. And so they're all about statistics and mathematics. They believe that science and nothing else. And that's the big problem we got. It's just, and that's where these tipping points come from. These tipping points are all future projections done by climate models. There's no evidence that anything has ever happened with a climate tipping point caused by man. Any of those that have predicted that they predicted haven't happened. The only kind of climate tipping point we've ever seen on this planet is when something natural has happened, like, with the Ice Age or with the Younger Dryas event, where, all of a sudden there was a sudden warming and it had to do with a change in the way that they believe a lake drained and it changed the salinity of the ocean and things like that. But there's never been any proof of a man-made climate tipping point happening. Sterling, you've been in this business as long as I have. Have you ever seen one?
No, multiple predictions. Fortunately, I guess we're not going to hear any more from Charles on this front. But we've been hearing it. I was hearing this before it was climate tipping points. It was various environmental tipping points. They've been predicting, the experts. We're always told to follow the experts. No, you follow science, and science is based on data, not models. The experts predicted we would run out of oil. The first oil scarcity
peak
prediction.
Oil.
Yeah, no, the first peak oil was was in the early 20th century when they were going to run out of oil because Pennsylvania surface wells were running out. They predicted it. The U.S. Navy predicted we would run out in the 50s. They were predicting we'd run out. When I was a kid, that was before me. When I was a kid, I remember very clearly in the 70s being told we would run out of oil by the 90s. And it wasn't just oil. The water would be so polluted that we couldn't use it. Scientists have regularly predicted things like, Paul Ehrlich, 200 million people die of starvation in the 70s. And he, and I believe Hansen, but I may be wrong about that, predicted that by 2000, parts of New York would be underwater. So,
Right.
It's not just climate tipping points, it's environmental scare tipping points. And I think if you want to really read, not just about tipping points, but about the idea why these things are always wrong. I'm reading right now uh, Julian Simon for a seminar I'm going to, who wrote this Resourceful Earth. I recommend the Resourceful Earth to anyone who wants to see how environmentalists and why environmentalists constantly make these tipping point claims, the sky is falling claims, and why they're wrong.
Yeah, they've been wrong very, very often, and they continue to be wrong. They produce new predictions regularly. Linnea, you've been in the oil business. Has there ever been any talk with the engineers and the geologists that you worked with about, another tipping point, peak oil coming? Do they ever see that, or do they think that there's plenty to be explored yet?
Well, with most people, there doesn't seem to be very much concern about some kind of a peak oil situation. I think for the most part, that narrative is pretty much left to the conversation. Just because, one, the people who work in the industry tend to have a better idea of the kind of volumes that we're talking about, and the fact that we're always finding new reserves, and the fact that, just because something might not be available economically now doesn't mean it never will be. So, in the day to day, you're not going to hear that very much. Every once in a while, you'll get someone who comes on the ship who isn't really familiar with the industry, actually. They just got the job to have a job. And you have to kind of challenge them on some of that stuff.
Right.
Because the kind of common belief is that we're running out, and that, any year now, we're just going to dry it up. And that's why there's all these, conspiracies and stuff about how the world works, is because it's a finite resource, which is true. But, so is almost anything else. And the quantities that we're talking about are just, it's not infinite, but it's certainly not in the next 100 years,
Right.
And that's just, petroleum stuff. That's just oil and gas. Coal, we have, that we know of, that we have way more. We have hundreds and hundreds of years of coal reserves. So
Right. And you can extract oil
it's
from coal
complete
too.
nonsense. Right.
Yeah,
And that
no.
stuff, it's wild when you talk to people about it.
Yeah,
But one
that
of
sums it
my
up. The whole argument. It's wild.
the thing that's struck me is that a lot of people seem to have this belief that our climate, or Earth systems, even have the ability to go into a positive feedback. I don't think that there's been very much evidence of that in Earth's history at all.
No.
The idea that, you can push something to a point where all of a sudden everything just collapses. It doesn't happen that way.
Yeah, it doesn't. And I think the analogy there is it's like to the human condition. You work and you work and you work, and all of a sudden you're just so dead tired you collapse. I think that people, environmentalists, tend to be, well, somewhat on the ecochondriac side of things, maybe more ecochondriac, where they think that the earth is going to, get sick and reach a point where it's going to collapse just like humans do. And so far, there's been no evidence of that. But let's go to what was the lead story this week all throughout the climate alarmism network. And here it is from The Guardian. Yes, the ever reliable Guardian, or some people call it the Graniad, because one year, ages ago, they misspelled their own name for the newspaper, believe it or not, and so it's been known as the Graniad. So Damian Carrington, who has been regularly talking about climate alarm, says that the world is on the brink of 5 disastrous tipping points. And, there's a study behind this. And obviously, this study is irrefutable because it's done by peer-reviewed science. He shows 5 dangerous tipping points that may have already been passed due to the 1.1 degrees centigrade of global heating caused by humanity to date. and that's the collapse of the Greenland ice cap, the current in the North Atlantic, and the carbon-rich permafrost, right? So all of these things are supposedly going to cause the collapse of the climate system, and the study itself was, it had 20 different climate tipping points that they identified in that. And it's not anything new. Back in 2011, the University of East Anglia, the famous ClimateGate folks that, were withholding information and, became the subject of the ClimateGate emails, they produced a study in a peer-reviewed paper saying early warning of climate tipping points. And they were so concerned about climate tipping points back in 2011 that they thought we needed to create an early warning system for them, kind of like for tornado warnings and that sort of thing. Maybe we'll have climate sirens going off in the streets, tipping point imminent, run for your lives. That's really the kind of thoughts that these folks had. And it's just absolutely nuts because, as Linnea points out, I've never seen any evidence either for any of these things happening at all. It just doesn't seem to be anything that's happened in the history of modern humans. It's happened way in the past with ice ages and things like that, but that's all been natural and not human driven. Comments from that, guys?
Well, they have a static view of resources in the earth as if it's this finite thing that technology hasn't figured, that humans haven't figured how to adapt to climates, various changing climates even over time, and B, adapt climates to us. Now, we can't say with certainty that we can always adapt, that we'll always be able to, but they've got no evidence that we can't. And they just assume that there's a fixed amount of oil, so we're going to run out of oil. Well, no, you know what? What's fixed at one time, as Linnea pointed out, it is dependent on economic value and technology. And so despite the fact we have used more oil and gas than was predicted to exist 50 years ago, and yet we have more reserves now than we had then. We're constantly finding not just more oil, but new ways to exploit. And that's, goes back, she mentioned coal, 400 years of coal. And as Anthony said, you can turn that into fuel. The South Africans did it when they were being boycotted during apartheid. The Germans did it during World War II. There's no evidence whatsoever. Water. I constantly hear we're running out of water. Has anyone noticed that 70% of the earth is water? Now you say, oh, well, we can't drink that. You can't water crops with it. Well, that's just false. We have desalination. Ask Israel, which gets a lot of its, probably a majority of its water from desalination. It's not cheap, but it's technologically feasible. And if California would do more desalination, they wouldn't have a lot of the water problems they're having constantly. So it's this idea that the world, there's a time slice of the world and it's fixed. And because it's fixed, we'll never have more resources. They will run out and we will all die. When they say tipping point, they typically don't just mean human civilization collapse. They mean, I think they really believe, some of them believe that the earth will become a dead rock in space if we don't do something.
Dead rock in space. That sounds like a musical group,
It'll be Mars or Venus. It's like, no, Earth abides. The earth will change, and some changes you may not like and some changes you may like. Right now, we're benefiting from a modest warming. If the next ice age comes, that's the big threat. And of course, that's what they were warning about in the 70s. And no matter what the tipping point, no matter what the environmental disaster, no matter what it is, what the prediction is, the problem is always the same. It's humans. And the solution is always the same. Big government, central control of people's lives, because the experts who've been getting these predictions wrong for as long as we can detail these predictions, who've always been wrong, they'll be right this time.
Yeah, there was a famous person, I think his name was C.S. Lewis, perhaps, who said that the urge for humans to warn of disasters and to save the planet and all that stuff is always a front for the need to rule.
It was H.L. Mencken. H.L.
Yeah,
Mencken
that's
said
right. That's right. And we've seen that again and again and again. Linnea, what are your thoughts on tipping points? Have you seen any lately?
Well, brief back to the desalinization comment. I do want to mention, California complains all the time about how they don't have enough water and how, the greedy Midwest is keeping all the water to themselves and they need, to build a pipeline from Lake Michigan so that California can have enough water. Well, they're willing to spend billions of dollars on offshore wind, on maintaining hydroelectric, on doing all this other stuff. And they're not willing to put a similar amount of money into a desalinization. And I read an article actually that just blew my mind. I think it was a newspaper out of San Francisco. People were concerned that they were going to raise the salinity levels of the ocean if they were doing desalinization locally in California because I don't know.
No,
California has.
These are folks that are unclear on how much water there is on the planet.
California has, they're either stupid or they have a real water problem. If they're consuming that much water, then we've got a worse problem than just desalinization to educate them on. I mean,
no, these are the same people who think that if we add, if a billion more people are added to the planet, we'll run out of oxygen because there's more people breathing. It's idiotic. And the idea that California gets shortchanged from the rest of the country with water. Oh, if only those Michiganders and the Wisconsinites would ship water to us. They've already drained the Colorado River. How much more does the rest of the country have to subsidize and support crazies in California by taking water that naturally, they say, oh, we love nature. Well, they don't like nature when it comes to water. California is naturally arid. It was one of the least populated areas in the continental United States when Europeans made landfall. And there's a reason. It's naturally arid. It didn't have water. But the federal government made it bloom like a rose under BUREC with dams. And the dams shipped water from the mountain states to California. And now they want more states subsidizing their lifestyles. That's crazy.
It is. And what's funny is that California has not built a new reservoir since, I believe, about 1978 when the New Melones Reservoir was built. And they haven't done anything really to improve their water storage. They haven't done anything to improve desalination, any other sources for water. And yet the population has practically doubled since then. And it's just totally irresponsible. And that's why the Colorado River has been going dry. But back to our main topic, tipping points and the whole science behind it, if you can call it that. Let's look at that I showed you earlier, that story from The Guardian, which talked about the 5 tipping points that are supposedly going to happen any day now, they're going to happen. So now that here's the science behind it, or the supposed science. This is a peer-reviewed paper called Exceeding 1.5 Degrees C Global Warming Could Trigger Multiple Climate Tipping Points. And it has a whole bunch of folks. They've got a cute little title, Getting Tipsy. Well, haha. The abstract basically is talking about that triggering climate tipping points will lead to significant policy-related impacts, including substantial sea level rise from collapsing ice sheets, dieback of biodiversity, Amazon rainforest, blah, blah, blah. We've heard all of these things before, and I showed you that one map where UEA had talked about these things way back in 2011, same set of things. And none of these have happened. We still haven't lost all the Arctic ice, even though Al Gore said it would be gone by 2013. We haven't had the Antarctic ozone hole get worse. All kinds of things that were supposed to happen just simply have not. And so if this was so bad, I decided to write a story about it. We put this on Climate Realism back in just a couple of days ago on September 13th. And I had a story commissioned, or rather a cartoon commissioned from our cartoonist that handles all of the climate stuff, Josh, who's over in England, he knows Damian Carrington pretty well. In fact, Damian has blocked him on Twitter because Josh says things he doesn't like. And so he made up this wonderful little cartoon about tipping point stage of view. And literally, we can go back through Google and find hundreds of instances of articles talking about climate tipping points that go all the way back to 1989. The most crazy statement ever by a UN official in 1989 was that entire nations would be wiped off the face of the earth due to sea level rise. Well, that never happened either. So anyway, we wrote this article about it. I wrote this article about it. One of the articles was from Grist, and they talked about how climate tipping points would, giant ice sheets, ocean current, permafrost, they may have already passed the point of irreversible change. 5 dangerous tipping points may already have been passed due to the 1.1 degrees centigrade of global heating caused by humanity to date, and onward and onward. And then they say here, get this, at 1.5 degrees centigrade of heating, the minimum rise now expected, 4 or 5 tipping points move from being possible to likely, and at 1.5 see an additional 5 tipping points. Yes, we get a bonus. 5 more tipping points at 1.5 degrees centigrade. Woohoo! Extra bonus tipping points coming our way. Bottom line is, they're not likely to happen. And let me tell you why. Now let's do some real science with real data, as opposed to this stuff we get out of climate models, which is speculation at best. Informed speculation, that's about all you can call it. The climate tipping points are all based on computer models. And the climate tipping points are always in the future, always, just years away. And they keep moving the goalpost forward when we don't reach these things. But here's the thing. They're all worried about 1.1 degrees centigrade or 1.5 degrees centigrade or 2 degrees centigrade or whatever it might be. They pick these numbers out of the air and then they model for those. What's going to happen when it gets to 2 degrees centigrade of warming? Oh my goodness, disaster is imminent. Well, not really. Let's take a look at this. We have here this graphic, and I'm going to examine this with the zoom here so you can see it better. This is from the Berkeley Earth data set of surface temperature for Europe. And the Berkeley Earth data set says that since about 1820, the temperature in Europe has risen 2 degrees centigrade. And the reason we're using Europe is that they've got one of the longest records of temperature on the planet, because they started measuring it way before we did in the United States. So we've already hit 2 degrees centigrade of warming. Where's those tipping points? I want those bonus tipping points. Where are they? Have you guys seen any?
Anthony, I think you're being grossly unfair. It might be the case. Yeah, it might be the case. And you just don't know that we actually live in a matrix world. And so the tipping points have occurred. Most, large continents have disappeared beneath the waves, but we just don't know it because we're living in the matrix and it's being modeled to make it, maybe that UN guy was right. When I traveled to South Africa a few years ago, it wasn't really there. It was just in my imagination that I was there. These people, these weird, non-data driven, model driven. Don't get me wrong. They use models, but they think they act as if models are science, and models aren't science. They're tools that, if used properly, can help expand knowledge, but they have to be used properly, and you have to see that they're functioning properly. And the problem there is climate models aren't used properly because they lack so many fundamental understandings of what changes climate. And so they have these huge assumptions built in. They don't. It's hard to control for one variable, but they've got to control for dozens of variables, and they're not. And then when they put outputs, the most basic output they do is what? Temperature. And so we can test that. We can test their temperature projections. They've been doing it for 35, 40 years now. How do they do? The modelers themselves say the models are running way too hot. We get the temperature wrong. If you don't get the temperatures right in these models, A, it's not clear to me they're that useful a tool, because that's all they are. But B, if you don't get that right, why believe anything else that they project? Why believe a single one of these tipping points would come to pass if they're based on the same climate models that can't get temperatures right?
Yeah, the only tipping point I know of in reality that has actually happened is cow tipping. I mean, that's a real thing, right?
That's a real thing. Now,
Yeah.
look, people, physical, organic beings can have tipping points, right? You drink way, way too much, and you don't just get drunk. You can have what's called a wet brain. Suddenly, you just go over the edge, and you become almost comatose. You're a vegetable.
Right.
There are real tipping points, but that's for organic physical systems. The Earth is not a single system. They act like it's Gaia. They bought into the Gaia hypothesis, but it's not a living thing. It's
Yeah.
a bunch of different systems interacting.
It's a model. It's just like everything else. Here's from our Climate at a Glance website. Tipping point. We talk about it. And it's basically this. You keep pushing the temperature uphill. You get to the imagined 1.5 degrees centigrade. And then the climate system destabilizes and it runs downhill into chaos. That's the whole science behind tipping points, literally. It's just simply not relevant anymore to do that. And so we haven't seen these things. Now, Linnea, when you worked in the petroleum industry, I'm sure you had models that you used, to determine the best places to drill, production, and so forth. But those things were not open-ended like climate models. Those things could be proven, right?
Well, you sure hope so. I mean, they're running, they'll create seismic logs. What I did a lot was worked with live drilling logs. So while they were drilling, we were getting data back from downhole about the temperature, the speed of the drill bit, anything you want pretty much, from a variety of tools, including sometimes gamma radiation that they bounce into the rock to determine what kind of rock formations we're drilling through. Just all kinds of fun stuff like that. But those are proved in reality models that you're working with right then and there. And if your previous seismic was incorrect, then you're drilling into the wrong formation, or you drill into something that you didn't expect. And well, you have to stop. But the difference is you're actually getting a real world result from that. And the difference between the petroleum industry and the climate industry is that in the petroleum industry, if your seismic turns out to be inaccurate, then you have to make adjustments in real life, accept the fact that it was inaccurate, and change your plan going forward in order to account for it. But what they do in the climate modeling is they say, well, we can just tweak the model so that we can pretend like what we're going through right now is what we said we were going to be going through. Man, if you pulled some of the stuff in the real world that they pull for these climate models, we'd be producing salt water and all sorts of junk from the Gulf of Mexico as oil, and they would just be going, no, you guys don't believe your lying eyes. We're definitely producing oil. The model said that we were going to be producing oil here, so that's what we're doing. And that would be pretty bad for everyone. So
there's another big difference between the oil models results and the climate model results, because the oil model results are done by private companies. If you keep getting it wrong, you got a business. People don't keep funding your models and your production activities. You fail. Climate models have gotten it wrong for 40 years now, and they keep getting more money
Right.
because it's government, because they're not held. The market doesn't control their funding. Governments control their funding. And because it's all about control and governments want control, they keep pouring more money into failed models and trying to pretend that they're accurate.
Right. And the models themselves, are very narrow in their focus. You know, we just had one of the comments here that there was like 28 variables on climate from one of the commenters there. Um, the climate system is not just one control knob from carbon dioxide, but that's the simplistic view a lot of these scientists and activists believe. They believe it's just carbon dioxide and it's nothing else. There it is. Carbon 14 Nobel laureate. Climate has 28 major variables out of the 1 million known. That's a lot of variables. And so when you got that many control knobs, how do you model that? The problem is you can't. You're trying to model a chaotic system. And the chaotic system itself is almost impossible because, you know, how do you model chaos? You don't. It's just not easy to model chaos because if you get one thing right, oh, you can model for this and you get a result. Well, something over here changes and that may affect this one. It's all interconnected. And that's the problem. Earth is a chaotic system. Everything is interconnected. Sunlight, rainfall, winds, temperature on one part of the planet versus another, the amount of solar insolation, the amount of clouds, just a 4% change in the amount of cloud cover that hits the planet or affects the planet could make all the difference in the world for the temperature rises that we have seen. And that's according to Dr. Spencer of the University of Alabama at Huntsville. He says, all we need is just this little bit of change in cloud cover, and that would explain all the warming that we've seen. And yet they can't properly model clouds in these climate models. They just don't have the technology or the expertise to do it yet.
By the way,
all you, Sterling.
Go ahead, Linnea.
Okay. I was going to say just, I think that we get a little bit of a glimpse that to an extent, or at least internally, they do understand just how complex it is and how many factors are affected. Because all you have to do is do what climate realism does every day and Google climate change and then look in the news section. And while the connections and the conclusions they're coming to are incorrect, what you'll see is they'll mention anything in the world and they'll tie it to climate change. To a point, they might be kind of right in some way. Not obviously not to the conclusions that they're talking about, but like, for example, you talk about, they'll say limestone erosion is contributing to climate change because it's releasing this gas or it's not fixing the right gases that we need. And so we need to stop climate change because this is a tipping point. You know, the cliffs of Dover or something are going to fall into the ocean and release all stored chemicals that they have. Something crazy. So they're going to become dissolved, and then the oceans will off-gas methane, and then we'll have a positive feedback loop, and the whole Earth will burn up to a crisp. Just something like that. Well, to a point, you know, locally, everything does impact it in some way. You know, your yard, one of your trees dies and all of its leaves fall off. Well, you might actually get a bit of a temperature difference in your yard from that. You know, you don't have the shade that you used to. So when you read these articles, you notice that there's like the tiniest glimmer of fact in there, but the conclusions they reach are all wrong.
Of hedging,
these are amplified facts.
Yeah, they've always got some hedging built in, but I'm going to disagree a little bit with what Linnea said and with what Anthony says. You know, he says everything is connected. I hear this all the time. Oh, a butterfly flaps its wings and a hurricane comes. No, there are redundancies and cushions built into the climate system. I do not believe any butterfly ever has flapped its wings and caused a hurricane. It's too small an impact, and hundreds of butterflies, thousands of butterflies flapping their wings don't cause hurricanes. Not everything may be interconnected, but it doesn't mean that a perturbation of one small part of a system affects the system as a whole. There are cushions built in. And the other, I think, often ignored difference, you know, because everything's compared to a greenhouse. And a greenhouse even a greenhouse isn't a closed system. The Earth is not a closed system. It's not a laboratory. Why? we have something outside of the Earth called the sun, and it's constantly putting out cosmic rays. Other things are putting out radioactivity. They impact the Earth, and that means we don't control that knob. It's an outside factor. So we aren't a closed system, but they keep treating the Earth as if it is a closed system. If it was a closed system, we wouldn't have to worry about meteors striking the Earth. That's the best proof I can think of that the Earth is not a closed system. The fact that the dinosaurs disappeared because of a meteor strike tells me, since the meteor did not originate inside the Earth, that this ain't a closed system, folks.
Well, if
Nope,
those dinosaurs hadn't been producing so much CO2, maybe the meteor would have missed them.
Yeah. Or if they produced more methane,
Yeah.
maybe it would have bounced off the atmosphere of the Earth. And I do think, though, we have to be careful when you say everything's connected to everything else. Well, yes and no, because not everything affects everything else.
Right. Just because just because everything is acting on everything around it at all, or that's not even accurate. You can't say that. That's a physics term that doesn't really apply, because not everything is acting on everything. But you know what I mean? There are localized effects by all sorts of things that happen. That doesn't necessarily cause a domino effect down the line of anything substantial.
Any wider connection.
So yeah, it's crazy how they will amplify little things like the butterfly effect. Now, I've known about the butterfly effect for a long time. I read James Gleick's book Chaos way back in around 1990, I believe it wasn't. By the way, he's the brother of Peter Gleick, who's, well, we don't talk about him much yet because he's done some pretty bad things. But his brother did write a great book called Chaos. And this book, Chaos, talked about the butterfly effect, about one small little thing, butterfly flapping its wings in Japan, causing, bad weather here in the United States. And while there might be a mathematical kernel of truth to that, I don't think there's any strong, regular reality to it. And here's the reason. There's so many other forces, much greater, going on in the climate and weather system in the Earth, in terms of things like tides and currents and solar insolation and clouds and everything else, that I think that these little tiny effects, while they might get amplified a little bit, tend to get swamped by these other things. And that's why we have a stable climate system as opposed to a chaotic climate. We have chaotic weather, which is the Earth trying to reach a new equilibrium in localized areas. But the climate system itself is relatively stable over the past millions of years. It doesn't have wild swings except for ice ages. And ice ages are said to be driven by Milankovitch cycles, precession, changes in the Earth's wobble as it goes around the sun. And it changes the insulation. And so that's been relatively well accepted in the climate community. But they think that there's, short-term effects like these little butterfly wing effects, like a little bit of extra CO2 going into the atmosphere, that's going to cause chaotic things to happen. And so far, there's just no evidence of it whatsoever.
I like to think of the climate sort of like a pool table, in the sense that the pool table has bumpers. I can strike a cue ball very hard and hit a lot of different balls, but it doesn't affect anything outside the table because it has cushions. Unless, of course, I'm really a bad pool player and knock the ball off the table, and then it might, hit my tumbler. There are impacts, but they are just like in the endangered species. When you're talking about species, I often hear, oh, this is a keystone species. Oh, this is a cornerstone species. There are some keystone species. If you take wolves out of the Yellowstone, beavers thrive, and it has all sorts of add-on effects. But there are lots of species that if they, I don't want them to disappear, but if they were to disappear tomorrow, the climate and the ecosystem in which they are in wouldn't care and wouldn't notice. They've got some snails in a very few particular hot springs, I think in Utah.
Isn't that escargot?
Arizona. They've got some snails that have only been discovered in one set of hot springs on one piece of property, and yet they've set up fences around it and netting to keep birds out of there because they were eating the snails and they don't want them to go extinct. Well, those snails are already in a pretty small
Precarious.
environment. Almost any changes, it's precarious. And the thing is, should they go extinct, we would have a loss of biodiversity. But what we wouldn't have is the collapse of the ecosystem in which there are.
Yeah, that's another common myth out there. You take away one or two species and the whole ecosystem collapses. Well, the bottom line is that ecosystems are opportunistic. One species disappears, another species is going to exploit that. That's the way of the life on the planet. They're going to go after that niche, that hole that's been left, and they are going to exploit it. So yeah, the ecosystem's not going to collapse. It's going to find its new equilibrium at some point in the future. It's just that simple.
This is something that we've talked about in previous videos before in passing, but the idea that it's pretty much just human beings that have a really, really hard time with change, and Yellowstone is the best example of that. Yellowstone has changed dramatically in terms of its appearance over the last 200 years, 300 years, as long as European settlers have explored that area and illustrated what it looked like at the time. And we don't like it. It very much upsets people, the idea that it might change into a more prairie-dominated ecosystem again, or shift to a way too heavily forested for our liking ecosystem. We really abhor any kind of alteration to whatever aesthetic that is going on in nature that we like right now. But nature really doesn't care. It becomes more plains focused, then the buffalo are going to be happy. More thickly forested, smaller animals are going to like that. It's impossible to keep nature on a leash like that.
Keeping nature on a leash is what we've been trying to do since man has existed, and we've been successful in some cases, but other times we've just made huge mistakes. Now, I'm going to try something new here on Climate Change Roundtable. I'm going to ask for our viewers to ask us some questions and comments, whatever they might be. Just throw out your questions and comments, and we'll see what we can do our best to answer them. And no question too big or too small. Feel free to ask.
And while we're waiting for those,
what you said, Linnea, is really critical. That's the problem. That's the problem, I think, with the environmental movement as a whole. They take a time slice view of history. They pick a particular kind of stage, a particular stage of an ecosystem, and say that's what nature should be, as if nature said that's what nature should be. But these ecosystems evolve over time. They go from climax forest to old growth forest. Absent intervention, they then decline in another way. Fires take over. In the plains, like you say, look, 300 years ago, buffalo were tromping everywhere, keeping the grasses down. The Native Americans on the plains were burning grass to keep the grass fresh and the trees out. Now there's more trees there than there were 300 years ago. But they looked at that when when the environmental movement was founded, the environmental movement really came into force. They looked at Yellowstone the way it was at some particular slice, and they said, oh, well, that's what nature intended. Had this, that, or the other. No, nature intends nothing. It doesn't have intention because it's not a living being. And ecosystems change at the local level, at the globe, at a regional level, and the planet changes. And I see no evidence, except at the local level, that we could substantially change the Earth. I mean, we can have knock-on effects in very short periods of time, very narrow places. Right now, Dallas, Texas, has more trees now than existed for the past probably 5,000 years, but certainly the last 500 years, because this was part of the Southern Great Plains. There weren't trees except along the rivers. Then we started putting up fences, and bird dropping started creating trees. And now we have laws that protect trees that aren't old growth trees, just because some guy likes the way it is now.
All righty. So we have our first question here, posted by a commenter, and here it is. This is from William Balke. He says, what are our views on deep bore geothermal electrical generation? Now, I'm not familiar with that term. Maybe Linnea might be, because of all of us, she's the most familiar with boring. No pun intended. Anyway, what what do you think about that? Could we generate electricity by sticking thermocouples in the ground at deep depths where it's really hot?
I think usually what they're talking about is moving water through. So it would be geothermal, like hydroelectric. So you pump water down the hole, or some kind of a fluid that handles supercritical temperatures a little better, and then the steam that's generated turns a turbine, which is like 90% of our electricity generation is done
So
that
it's
way, even
basically
nuclear.
a controlled
Um,
Yellowstone geyser, right?
yeah. So I don't see any reason to oppose it. If the technology were to prove itself, I think it would be pretty cool. The funny thing is, it's actually seen some pushback from the environmentalists because you have to frack for some of that technology. They tend to
Oh,
frack so that you can
no.
get better surface area conductivity between the water and some of the surfaces. I haven't done a ton of research into this. It's coming up in my energy series, but it is. I think it's an interesting idea. It's, from what I understand, very expensive, more expensive than drilling for oil for whatever reason. I'm not sure why that would be. But I think it's, worth a shot. I don't want to subsidize any of it. I don't want it to become some
That's
like, we need to use 10%, 10% geothermal by 2030 kind of a thing. I don't want that. But I wouldn't want that for any resource. But I think that's generally the stance of Heartland.
Yeah, no, that's right. Geothermal has its place if it makes sense in the marketplace. There are surface, low, shallow geothermal uses all over the world. I think Iceland gets most of its energy from geothermal
Yeah.
because, well, they sit atop, very active volcanoes and geothermal vents. Where it makes sense, people can do that, and it can produce energy. Now, you have to worry in some places. A few years back, a religious group outside of Yellowstone started tapping into the geothermal there to power their systems, and they started noticing in Yellowstone that the geysers weren't working quite as well, and they ended up stopping that. The government said, no, you can't do that. I think they took their land and bought it out, did a takings. So you have to worry about that in these sort of shallow uses. The deep uses, I think there's two critical questions before we go down that path. And that's, is it necessary? It may be a good idea if we needed it, but with what we have in coal and natural gas and things, unless you believe climate tipping points are in the offing, it's not clear that we need it at this point, at this stage of technology and the cost. And that's why we may not need it, because it would be so much more expensive than other resources.
Yeah, the bottom line is that fossil fuels are still one of the most compact and least expensive energy sources available to us, and the most reliable too, because gosh, they work at night and when the wind doesn't blow. So here's our next question. We have here: is it safe to say the main climate control knobs are the sun, water, and planetary motion? Well, that's an interesting question. What do you guys think?
I think it'd be hard to narrow it down, but in terms of things that make this planet unique, I think water probably plays a pretty huge moderating role in our climate. So water can act as both kind of an insulator in the case of water vapor in the atmosphere, so it can keep some warmth at the surface. And it also acts as a coolant in terms of evaporative cooling. So I think that's, Anthony, correct me if I'm wrong, but I think that's part of the reason why they have trouble with the cloud modeling, is because they haven't quite figured out whether or not clouds, and in what cases clouds contribute to either warming via insulation or cooling. So it's complicated.
Because they reflect
it is very
cosmic rays
complicated.
back to
What's that,
Yeah.
Sterling?
But with the clouds, because they reflect cosmic rays and solar back into the atmosphere before it reaches the ground. So it depends on the type of cloud, actually.
Yeah, it is. It does.
What it's doing. And I think, I guess I would just agree with her. I think it's too complicated to know all the control knobs. I don't think we know yet, but I think those three are pretty much the main. Once you consider, when you say water, you consider water vapor in the atmosphere. It is the dominant gas in the atmosphere.
Right.
Not by a small amount. As much as we hear about CO2, water vapor is about 97 to 98% of the greenhouse gases in the atmosphere. So we're talking, when we talk about CO2, 1 to 2%. And that's not the controlling factor.
Yeah, a colleague of mine, Willis Eschenbach, who publishes on What's Up With That, has identified what he calls the thermostat hypothesis for clouds. And it happens in something called the intertropical convergence zone, which is basically a ring of clouds that go around the equator that only appear during the daytime and then disappear at night. And he's pointed out, and he's done a lot of data from insulation from solar radiation. He looked at that data going to the surface and reflecting back out into space. And basically, he's been able to show that the Earth regulates its temperature by clouds along the intertropical convergence zone, the ITTZ. And so what happens is that during the morning, we start heating up because of the sun. Water vapor evaporates from the surface of the ocean. It goes up. It starts forming clouds. As we get more solar radiation on the surface of the ocean, more and more happens. And we build up these giant thunderstorms. And that's the tipping point that happens. This is a real tipping point that happens every day in the climate system, but it's not one that's malevolent. It's very benign. It's helpful. So what happens is the clouds build up. They start reflecting more solar radiation into space because they're bright white as far as the Earth is viewed by the sun is concerned. And there we go. You can see that these things build up. And so they act as a regulator, a thermostat. They start reflecting solar radiation back into space. And then as the Earth turns and the sun starts fading a little bit along the horizon, they start dying down. They reflect less, and they're a natural thermostat that regulates the temperature of the Earth by the fact that they do two things. Number one, they transport heat from the surface of the planet to the upper part of the atmosphere. And number two, they replace that with downwelling colder air from the upper atmosphere as part of the circulation. And then number three, they act as a reflector to prevent things from going into runaway. And that is a natural phenomenon that happens every day along the equator. So let's see here if we have any other questions that we should take a look at.
I saw one about fracking and earthquakes that I think I'll answer quick. So the quick answer is kind of. So basically, a lot of the times when the media reports on what they're calling fracking, causing earthquakes in places like Oklahoma and some parts of Texas, it's not that they are fracking for oil as they would in a normal drilling and production kind of circumstance. A lot of the time, in fact, all the times that I can think of, it's usually when they're doing a wastewater injection well, which deals with much greater volumes of water that are intended to stay down in the hole. This is something that's mandated by the government. They say, you can't just dispose of this water anywhere. So what you can do is you can re-inject a certain amount into certain types of wells. And what they have found is that the volumes and the pressures involved have caused some small earthquakes. And when I say small earthquakes, I mean, if you stand 2 rooms away from the kitchen and someone in the kitchen drops a gallon of milk on the ground, that's about the level of tremor that we're talking about with those. So they come up on a scale if they're trying to detect it, but it's really not anything that's going to shake your windows out. In terms of regular fracking, which is just where you're injecting water and sometimes small explosives used to create cracks in the rock, and then they pump a bunch of usually like a saline solution with sand or something like that into it to keep the cracks open. That not really. That's not really causing earthquakes. I could be wrong, and there could be some very minor ones that have been caused by that. But almost every time that I've investigated to see what they're talking about in these articles, it's almost always a water injection well.
Right.
Yeah, that's
That
right.
there was a lot of that in Oklahoma, as I understand.
Yeah.
And North Texas, not too far from me, we had some of that. It's the intensity and the pressure of the water, because you've got a lot of different fracked wells disposing in one formation that that wasn't geologically active, but became active. There was a fault, and it became active in a minor way because of the pressures of the
Right.
injection.
If you
It's
pick
not the
your
fracking
well,
itself.
yeah, if you pick your well, your wastewater well, or something goes wrong with your seismic when you're trying to determine where in the formation you are, I'm sure that there have been cases where if you are near to a fault line and you are doing a wastewater injection well, you could probably cause a fault slip in a very localized way that could cause a very small earthquake, but it's not going to be something that's going to even rattle your plates off the china cabinet, nothing like that.
Right. And back to our original premise, there's no tipping points in fracking. You inject water into the wells. Okay, so you may cause a minor earthquake, maybe a 2.5 or something like that. But there's no giant earthquake that's ever happened due to fracking. No tipping point type of an earthquake, right?
No. Anthony?
No tipping points.
You may have discovered, however, a tipping point. When you were talking about Willis Eisenbach's, maybe the cloud changes in the sun are a tipping point, that when you get to a certain point, the cloud formations change and their actions work. I think probably that's similar. I don't know Willis's work, but I know Richard Lindzen's work. It's probably similar to some of the stuff that Richard Lindzen has hypothesized and written about how the upper atmosphere, clouds in the upper atmosphere, are a control knob for the climate, for temperatures.
Right. All righty. Well, I think we've kind of covered tipping points and reader questions pretty well. I'm going to leave with a final thought in that, and from my viewpoint, tipping points, depending on the service, are somewhere between 15 and 20%. Oh, come on. You didn't get it? All right. Any other final thoughts?
Bad. No, I think that we have a terrific audience and they have good questions, and I'm sorry that we can't get to all of them.
Yeah.
And that we don't get to more of them during the week, other weeks. Yeah.
Well, we'll set apart. I think it'd be a good idea to set aside these last 15 minutes, as long as the audience wants to, and they're good with us maybe trimming down the content a little bit to have a Q&A at the end of videos. I think that'd be really fun.
Okay, cool. All right. Well, thanks everybody for joining us today here on Climate Change Roundtable. We're here every week on Friday at noon Central Time, and we'll be tackling new topics on climate every week and answering your questions. For Linnea and Sterling, I'm Anthony Watts, Senior Fellow for Climate and Environment for the Heartland Institute, wishing you a good day and goodbye.